Welcome back, everybody, to Block 4, where we begin the second half of our Calculus 1 course. Let me just fix the light here. Here we go. So we're going to begin a little bit where we left off on the topic of derivatives. Today, the topic of discussion is implicit differentiation. So let us actually start with defining what we mean by an implicit differentiation. So basically an equation describes a function given in an implicit form if the equation contains both x's and y's, if the equation contains both x's and y's, and the y's are either difficult or impossible to isolate. Are either difficult or sometimes just barely impossible to isolate. So it's a rather extensive definition, lots of words, to actually say something fairly simple, i.e., it's impossible or difficult, it's, let's just say, hard, difficult, to write y as a function of x. So that's what an implicit function is. Not an implicit derivative yet, but an implicit function. So it's a function that contains x and y, and the y's are actually difficult to isolate. Let me show you an example of what I mean. So let me get rid of this. So why don't we consider as an example, consider the implicit equation. Let's change colors. X squared minus xy plus y squared equal to 0. Okay, so as we mentioned, this equation has both some x's and some y's in it. So can we isolate y? Can we isolate y? Let's try. It's not usually a very complicated strategy to isolate y. We keep the terms that have a y on one side and move the terms without a y on the other side. So this has a y, and this has a y. The only term without a y is the x squared, so we move it to the other side, minus x squared. That's the standard strategy, isn't it? Then we factor out a y from here, and that's going to normally lead to the isolation of y. So to take out a y, you're going to get minus x plus y, right? And then you're going to divide by the bracket. So technically speaking, we have followed the code of algebra here in order to isolate y, and we're getting this. And basically, this is a big fail. Why is it a big fail? Well, because right here you have a y, and right here you have a y as well. So we were trying to isolate y, but we find ourselves with y's on both sides. So we were not able to isolate the y. As a matter of fact, it's still possible to isolate the y, but it's cumbersome, it's complicated, and we're not going to get into this type of algebra. So this is an example of an implicit equation. So hence, the equation that we started off with, the equation x squared minus xy plus y squared equals to 0 is an implicit equation because isolating y here does not work. It simply fails. That being said, it doesn't mean, if we can't isolate y, it doesn't mean that we cannot take the derivative. And since the object of the course is to derive functions, let us see how this can be done. So I will erase this and move on to the next whiteboard, which will be just entitled, how shall we entitle this? How to obtain f prime of x from an implicit equation. Now, recall that y equals f of x. So this means that f prime is the same as y prime, right? If y is equal to f of x and I take the derivative on each side, keep in mind that y prime is the same as f prime. Notation wise, this actually will matter a little down the stretch. Okay, so how do we do this? Basically, the technique is simple. So that's what it is. It's a technique. I will describe the technique in 3 steps. Step 1, prime. Okay, we all know what that means in this class. What does it mean to prime? It means to derive, yeah? So derive both sides of the equation. So you prime both sides. You derive both sides of the equation. Step 2. Bring all the terms with a y prime in them on the same side. Finally, step 3, once we brought all the y primes on the same side, isolate, or should I say factor out y prime and isolate it. So factor out y prime and isolate it. That's the technique. It's a simple technique. So where we're given an equation like the one we had before, and I'm going to come back to that very equation, here's what we do. We prime both sides. All the terms that will contain eventually a y prime in them are going to be brought to the same side. And basically we factor out the y prime and isolate it. Just remember what we're looking for here. Remember what this problem is about. Remember, we want y prime. In the end, we will actually require to know what y prime is. Good. Let's see if we can apply this technique on an example. Why don't we pick what we had before? So let me get rid of this. This whiteboard is tough to erase. So Example 1. Example 1. Consider this, if you're taking note of the starage, this is 2.5 stars. So find y prime. So find y prime if y is given implicitly by, what is it that we had? X squared minus xy plus y squared égale 0. All right, step 1. What was step 1? Remember? Step 1, prime both sides. So x2 minus xy plus y2 prime égale the derivative of the right side, which is the derivative of 0, which of course is 0. Now how shall I derive the left-hand side? Well, I got a minus and a plus, so let me take my time and take the steps here. So this should go x2 prime minus xy prime plus y squared prime. And like we said before, the derivative of 0 is 0. Some of these go from the easy to the not so easy, perhaps even to the tricky. This is easy. This is not tricky. Rule 4, the derivative of x squared is 2x. What is this? The derivative of xy, how would you take that? If you're thinking that there is a product between the x and the y, you are correct. We shall apply the rule for the product. We shall apply the product rule. X prime y plus xy prime. We will come back in evaluating some of these guys onto the next step. Now here's a tricky little dude. Y squared, the derivative. Okay, the derivative of x squared is 2x. Rule 4, that's settled. What is the derivative of y squared? Is it 2y? You think? Think again. Because y stands for what? What is it that we have to keep in mind here in these types of problems? Remember that y is the same as f of x, right? So when I find the derivative of y squared, I'm actually finding the derivative of f of x squared. Am I not? Am I not? See? It takes a lot more space to write, but it actually says a lot more what this is about. So y squared is actually the very same as f of x all squared. And that brings me to what? Chain rule. Power rule for function. Yes, sir. Yes, ma'am. All right. So let's see what we got. X prime. That is rule number 2. That is 1. Don't even need to write it down. Plus x times, what is the derivative of y? Is it 1? No. X prime is 1. What is y prime? Y prime, we don't know, because we are trying to find y prime. So you know what? Y prime is y prime. It is what it is. I can't change it. Here comes my power rule. Here comes my chain rule for function. Bring the 2 in front and the power goes to minus 1. So 1, right? The power. Times, if you remember chain rule, you need to take the derivative of the inside. So times f of x prime égale à 0. Good. We're almost done with step 1. So this is 2x minus y minus xy prime. What did I do here? I took the minus inside the bracket. Plus, now you tell me, what can I do about this f of x right here? What can I do about this guy, f of x? What can I replace it with? F of x is y, and f of x prime is y prime. So 2y, and this guy, and f of x prime, this is going to be written now as y, because f of x is y, with a prime. So y prime. As you can see, you have here a concise form of the derivative of y squared. The derivative of y squared is actually 2y times y prime. We're going to meet that sort of chain rule again in later problems today. Now here we go. Is there any more derivative that I can evaluate in this line? No, because there's a y prime, and y prime is what I'm looking for, and there's another y prime here, so I can't find that. It is what I'm looking for, so step 1 is done. Step 1 is over. Okay, so step 2. Step 2. What is step 2? Bring all the terms that contain a y prime to the same side. Okay, dokie. So minus xy prime plus 2y y prime. That is equal to, okay, so this guy stays because they both contain a y prime. Those two other guys do not. So they move to the other side as minus 2x plus y. And in a nutshell, that is step 2. Absolutely. Now, since I'm running out of room, I am going to complete the problem on top of the whiteboard. I'm going to make an arrow here. And we're going to finish the problem right here with step 3. What is step 3? Isolate the y prime from the left-hand side and basically finish isolating the y prime by division. So I'm looking at this. I'm going to take out the y prime from here. I'm going to take out the y prime from here. What will I be left if I take out the y prime from this guy? I'll have minus x. And if I take out the prime from 2y y prime, plus 2y. The right-hand side will remain as it was, minus 2x plus y. Finally, we are there, and we are going to isolate y prime by dividing both sides by the bracket. So minus 2x plus y divided by minus x plus 2y. This is our final answer. We have found what y prime is. Please notice that the equation, the answer for y prime, will contain both variables x and y. This is typical of implicit differentiation. So that's our first example. I hope it was clear enough, but very often one example is not enough. So let's take a look at another one. I'm going to get rid of this now. Okay, so example 2. Let's hike up the stakes perhaps to 3-star maybe. Example 2. I don't know, 2.5, 3 stars. Sometimes there isn't much of a difference between the two problems. So what shall we get? We shall say find, again, pretty much the same formulation. Find y prime if, what shall we say? We shall say something like minus x y squared plus cos y is equal to 3x. Once again, I have x's and y's that are tangled up, if you want, in the same equation. because we have a y in a cosine, I can already say that it's going to be not easy to isolate the y, especially if I have a y squared term before it. So I'm not even going to try to isolate the y. I'm just going to go straight into my three-step technique to find y prime. Step 1. What is step 1? What is step 1? Derive both sides, so prime both sides. So minus xy squared plus cos y is equal to 3x. We shall prime both sides. Okay, there's a plus, so minus xy squared prime cos y prime. Good old rule 6, always useful. And that is rule 3. The derivative of k times x, or c times x, is just c. So we can take care of that right now. Again, you will notice that between the x and the y squared, there's a hidden little multiplication sign here. So we have got to apply the multiplication rule. So we know this well. Rule 7 minus x prime y2 plus minus x y2 derivative. Plus, what is the derivative of cos y? Well, the derivative of cos x, that's rule 10 minus sine x. But that's not cos x, it's cos y, and y stands for f of x, right? So this is actually like cos u. Let me put this aside. Cos y, oh, my blue is dying. So cos y is like cos of u. And how do you derive cos y? Well, you derive cos y as you would derive cos u. So there's going to be a chain rule that is attached to the derivative of cos u. What's the derivative of cos u? You remember the chain rule. It is minus sine u times u prime. Aha. So since we have established that y is like u, then this derivative is like minus sine of y times y prime. It's exactly like a u. So plus minus sine of y times y prime. Because of chain rule, because this is not an x, it's a y. So the y is like a function f of x, or like a u. Then we need to apply the chain rule on this. That's minus 1 times y squared. And this is the same guy we saw in example 1, the derivative of y squared. So we know how this works. We're not going to do it again. We saw in the first example that this gives us 2y y prime minus sine y y prime. Now, at this stage of the problem, I'm looking at this and I'm saying there are still some derivatives involved, but those are the derivatives of y. There's a y prime here, and there's a y prime there. And these, I don't know. Why is it that I don't know what y prime is? Because the question says find y prime. So I do not know what y prime is, meaning I am ripe and ready to go to step 2. All my derivatives are taken. Step 2, keep on the same side all the terms with the y prime. You have a y prime, you have a y prime, so minus 2x y y prime minus sine y y prime. These are the terms that contain a y prime, the second term and the third term. And I'm going to take the only term that doesn't have a y prime and move it to the other side. From minus y squared, it's going to become plus y squared. And as usual, step 2 is quick and relatively painless. Step 3, factor out the y prime and isolate it. Factor out the y prime from this guy. Factor out the y prime from that guy. and you are left with this. Finally, divide both sides by the bracket, and this is our strangely looking final answer of what? Y squared all over minus 2xy minus sine y. That is my final answer. This is the answer I want to give in. Looks weird with all the x's and y's on the right side, but it is the correct answer. Good? Good, good. Maybe one last example on implicit. So let me get rid of this. All right. Exemple 3. Also, 3 stars. Find the slope of the line. Okay, you can recognize my type of question. Of the line what? Tangent to the graph of f of x given implicitly by, now I should give you the equation, something like x squared plus y is equal to y3 minus xy squared minus 1 at the point 1, 2. So find the slope of the line tangent to the graph of f of x, and my f of x is given implicitly by this guy, and I want the slope of the tangent line to the graph of f of x at the point 1, 2. I'm not even going to try to isolate y from here because there are y's and y squares and y cube and y naught on either side. So let's go straight into our little technique. Let us do step 1 and let us prime both sides. All right, prime both sides. So that would be what? X squared prime plus y prime is y3 prime minus xy squared prime minus 1 prime. So 2x plus, what is this? That's what we're looking for. As usual, we want y prime, so we're not going to evaluate this. This is just y prime. Hey, look at this guy, y to the power of 3. I'm going to use what I used before, the power rule for function. Bring the 3 in front. Y to the 3 minus 2 times what? What's the derivative of the inside? F prime, but f is y. So y prime minus, okay, xy prime, we've seen that before. Xy prime, we've seen that before. So let's just redo the steps anyway. So x prime y squared plus x y squared prime, and the derivative of 1 is 0. So I'm not even going to write it. So what do I have here? 2x plus y prime equals 3y squared y prime. And that's a y prime, not a y1. And there's some action in here. X prime is 1 plus x times, again this guy, for the 3rd time today, the derivative of y squared is 2y times y prime. Okay, let's clean this up a little bit, and we have step 1. So 2x plus y prime equals 3y squared y prime. This is minus y squared, and this is minus 2xy y prime. Okay, so a product rule and a chain rule in these problems. Maybe it's a 3.5 stars, I don't know. Step 2. Step 2 is usually easy. Bring all the terms with the y prime to the same side. So y prime is already on the left. I'm going to keep it there. And I'm going to move over this guy. So minus 3y squared y prime. And this term also has a y prime, so it's moving. Plus 2xy y prime. Left on the right side is this guy who doesn't have a y prime. And moving to the right side is the 2x that doesn't have a y prime, so minus 2x. And step 2 is complete. Let's move over here. Step 3. Take out the y prime. What do you have if you take out the y prime from here? 1 minus 3y squared plus 2xy equal to minus y squared minus 2x. So taking out the y prime is easy, it's simple factoring. And now we divide both sides and we have a y prime. So it's minus y squared minus 2x. All of that over 1 minus 3y squared plus 2xy. Now remember, y prime is what we're looking for, but it stands for f prime, the derivative of the function. And that is the slope of the tangent line. The derivative is the slope of the tangent line. So all I got to do now is plug in the point, and I will find that my slope of the tangent line is given by whatever that turns out to be when I replace both the x and the y with the point 1, 2. So here both the x and the y will have to go in. So minus y squared minus 2 times x over 1 minus 3 times 2 squared plus 2 times 1 times 2. What is that? I guess the top is minus 6. And I guess the bottom is, what is the bottom? That is 1 minus 12, that is minus 11. And minus 11 plus 4 is minus 7. Is that right? That's minus 12 plus 5 is minus 7. So final answer, the slope of the tangent line is this value, 6 over 7, because we can cancel the negatives. Okay, well, that's it for the one and only, won't be another one, lecture on implicit differentiation. I'll see you soon when we start some applications of the derivative. You take care now.